These are notes for section 9.1. Okay, section 9.1 here, page 503, 1 to 77 odd. So there's up to 25 or so. Some more. Video. And then the answer is in the back of the book. See 9.1. Here we are. Okay, so I think you can see the left side. Let me scroll over to the right side to catch any comments from over there. All right. Good. Okay, as you can see, we're doing roots and radicals now in section 9.1. Okay, here we go. Okay, for this section, some things to keep in mind. You want to be familiar with the perfect squares. You basically already know these. Perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Okay, these have nice square roots. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 49 is 7, and so on. You've already known these from the times tables. A little bit harder to know are the perfect cubes. So 1 cubed, 1 times 1 times 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 cubed is 64, 5 cubed is 125, and so on. You say, do I have to memorize these? No, you don't have to. Maybe I would say up to here you should be somewhat familiar with these, up to 125. After that it's a little bit tougher. But there we go. Okay. We also have occasion for perfect fourth powers. You definitely don't want to memorize much beyond what I have here. 1 to the fourth power is 1. 2 to the fourth power, 2 times 2 times 2 times 2 is 16. That's not that hard. And 3 to the fourth power, 3 times 3 times 3 times 3 is 81. After that, it's probably not worth memorizing. Okay, number 1, square root of 144, 12. Okay, square root of negative 144, so you call it a minus sign, comes outside, stands up as an I. And square root of 144 is 12, so 12i. Now, you can take the cube root of a negative number. It'll be a negative. The cube root of negative 27 is negative 3. I don't have to do any of the I stuff because negative 3 cubed is negative 27, so that's fine. Fourth root of 16, as we said, is 2 because 2 to the fourth power, 2 times 2 times 2 times 2 is 16. Therefore, the fourth root of 16 is 2. Okay, cube root of 0.008. Now, you know the cube root of 8 is 2, so it should not be that much of a stretch to guess cube root of 0.008 is 0.2. You have to be careful with the zeros, but if you take 0.2 times itself, you get 0.008. Okay, 17, we're assuming that A represents a positive number now. If A is negative, it's a little bit trickier. But for A positive, square root of 36 is A to the 8, square root of 36 is 6. The square root of A to the 8, what times itself is A to the 8? That's A to the 4th, because A to the 4th times A to the 4th is A to the 8. Okay, cube root of 27, A to the 12th. Cube root of 27 is 3. What do you cube to get A to the 12th? A to the 4th. A to the 4th cubed is A to the 12th. And you may notice a nice shortcut. It's basically 12 divided by 3 is 4. 8 divided by 2, understood, is 4, and so on. So we can use that shortcut for this one. Fifth root of 32, x to the 10th, y to the 5th. We might not be comfortable with fifth root, but there isn't that much to try. Fifth root of 32 comes out to be 2, because 2 to the 5th power is 32. Okay. Now we'll play the game as we did before. It's basically 10 divided by 5 is 2. 5 divided by 5 is 1, so 2x squared y. Okay. In other words, if I take this and raise it to the 5th power, you get this back. 2 to the 5th is 32. X squared to the 5th, 2 times 5 is 10, x to the 10th, and y to the 5th is y to the 5th. Okay, now we have some fractional exponents. How do we deal with fractional exponents? A to the b over c. You have a fraction. The number on top is a power. The number on the bottom is a root. Okay, a memory trick. Think of the root of a plant. The root of a tree is further down, so the root is down, and the power is up. So a to the b over c means this or this. A to the b power and take the cth root, Or you can take the cth root first and then raise to the b power. This is easier to write, but in terms of computation, this is normally easier to do. Normally when you take a root, the number becomes smaller, and then when you take the power, it gets bigger. Okay, so we normally would rather do it that way than to start off with the power. That usually gives you a bigger number, and it's harder to deal with. Okay, 36 to the 1/2. Okay, the power is 1, the root is 2, and both of these are understood. You don't actually have to write the 2. You don't actually have to write the 1. So it means square root. Square root of 36 is 6. Okay, so when you raise something to the 1/2 power, it means the same thing as square root. Okay, negative 9 to the half. You have to be a little bit careful here. It's not in parentheses. If it were in parentheses, you could be taking the square root of negative 9. But like this, the negative is like negative 1 times 9. So that's a multiplication. That's an exponent. Exponent has precedence. So it really means you do 9 to the half first, and then put a negative in front of the whole thing. So you just put the minus, square root of 9, so negative 3. Okay. And you can see here, if it's in parentheses, then that's the thing you're doing the operation on. That's the power, that's the root. But if the power is 1, you don't even have to write it, and it's a cube root. So cube root of negative 8 is a real number. It's negative 2, because negative 2 times negative 2 times negative 2 is negative 8. Okay, 37, blah, blah, blah to the 1/2 means square root. Square root of 81 over 25. Square root of 81 is 9. Square root of 25 is 5. Now this is a little bit tougher. 27 to the 2/3. Okay, so this is the power, this is the root. So I'm going to take the cube root and then square it. Now you say, can I square first? Yes, but 27 squared, what's 27 squared? That's a lot harder. You need to use a calculator, but you probably wouldn't be able to do it in your head. But I can do the cube root of 27 first, which is nicer. Cube root of 27 is 3, and then 3 squared is equal to 9. Same thing here. 16 to the 3/4 power means I do the 4th root and cube it. Or you can cube first, but I don't want to do 16 cubed. That's a really big number, right? 16 times 16 times 16. You can avoid that if you do the root first. Okay, so again, this is called the radical sign or radical symbol. Okay, so the 4th root of 16 is 2. It's a perfect 4th power, right? So I'm taking 2 to the 3rd power, 2 cubed, which is 8. Okay, now we're combining a lot of stuff here. 27 to the negative 1/3. The negative exponent means put it in the denominator. So 1 over 27 to the 1/3. All right, so that means cube root of 27. So what about the power? Well, the power is 1. So if you raise something to the first power, it's the same thing, so you can just forget about it. And the cube root of 27 is 3, so 1/3. Okay, 25 over 36 to the negative 1/2. The negative exponent to a fraction means flip the fraction. So 36 goes on top, 25 goes on the bottom to the positive 1/2. Okay, so negative exponent on a fraction, flip it to the positive 1/2. And we know 1/2 means square root. So square root of 36 over 25, 6 over 5. Okay, 55, they ask you to add 2 things, so no big deal. Figure this out, and add it. Okay, if you raise something to the 1/2, the power is 1, which means don't write it. The root is 2, which also means don't write it, right? This is understood to be square root. 27 to the 1/3, the exponent is 1, don't write it. Cube root. Okay, square root of 16 is 4. Cube root of 27 is 3. 4 plus 3 is 7. Okay, then 65, x to the 5/6 over x to the 2/3. We're supposed to subtract the exponents. So a little bit of scratch paper here. 5/6 minus 2/3. Common denominator 6 multiplied by 2 over 2. 5 over 6 minus 1, 4 over 6 is 1 over 6. So the answer is x to the 1/6. Okay, 67 looks kind of scary, but you're really just multiplying fractions. So we distribute the 3/5. It's 3/5 times that, and that. Okay, so I work on the fractions. 3/5 times 3/5, 9 over 25. 5/6 times 3/5. The 5s cancel out. So you have 3 over 6, which reduces to a half. And then z to the 1/3 times 3/5. The 3's cancel out, so I have 1/5. And finally, 73, blah, blah, blah to the 8th power. You can distribute the 8. 8 times that, 8 times that. So negative 1/4 times 8 is -2. 1/2 times 8 is 4. Okay, and then a negative exponent means bring it into the denominator. So final answer 1 over a squared b to the 4th power. Okay, so that was section 9.1.